So, without any further ado, here is Jim Sorensen from the University of North Dakota. Subsurface Research and Development is his game. He's the director of that at the University of North Dakota, geologist, too. Jim, thanks for taking the time for us. We appreciate it.
Yeah, thank you, Scott. Thanks for having me on. And that was a wonderful introduction to the topic here. And what I was going to talk about is share with your listeners a little update on some work that the EERC has been doing for Minnesota Power Corporation, or Co-op, Minnesota Power Co-op, their Project Tundra out there where they're looking to capture CO2 from the Milton R. Young Power Station and take that CO2, and one of the things we're looking at doing with it is injecting it into a deep geologic formation for permanent storage, as you say, help reduce greenhouse gases getting into the atmosphere. And so one of the things that we were doing at the EERC here, again, working with Minnesota Power Cooperative, was from mid-May to mid-June, we were out at a location near Center, North Dakota, which is a little ways just north of Bismarck there. And Minnesota was drilling a well, and the purpose of that well was to collect some geological data and ultimately have that well serve as a future monitoring site for that Project Tundra injection. And the EERC was there to help select where to collect the core, describe and catalog the core that was collected, oversee some of the testing operations in that well, and also collect some water samples.
So,
in
that process, I'm curious, Jim, are you actually storing CO2? You're testing the ability to store the carbon dioxide in that field work?
That will be the ultimate goal. That's sort of the next step. Ultimately, one of the next steps right now, the purpose of this well was what we call a stratigraphic test well to understand the geology. As you know, you may or may not know, we're working in what's called the Williston Basin. It's a big bowl that stretches from the Red River Valley all the way out to eastern Montana, from South Dakota to Saskatchewan. And the bottom of that bowl, south of Williston, is about 15,000 feet deep. That bowl is filled with many, many layers of sedimentary rocks, and some of those rocks have porosity and permeability that make them perfect for injecting CO2 for storage. And so what this stratigraphic test well is designed to do is collect samples of different sedimentary layers to understand the properties of that rock, to make sure that they can have enough capacity for CO2 storage and that they can safely keep that CO2 in place. And we've identified some layers that we think are perfect for that. And from a sort of a science geek standpoint, this well is unique in that we went all the way down, like I mentioned. We've got this bowl full of sedimentary rock, and at the bottom of the bowl is what we call the basement, which is this crystalline, granitic kind of rock that's over 1 billion years old. And we're talking some of the oldest rocks in North America. And Minnesota actually collected about 70 feet of that basement rock. And to put that in perspective, there have been over 30,000 wells drilled in North Dakota. Only 14 have core from the basement rock. So it's really important that we understand the geology from the basement all the way to the surface if we're going to safely store large quantities of CO2.
That is really interesting. Now, what kind of a timeline is on? I know I've asked Mac this from Minnesota Power as well, and it's not something you have circled on the calendar that it'll be done by this day, because obviously a lot of steps and a lot of moving parts to this as you talk about getting ready to kind of test that. And then before, I get it. It's not something you snap your fingers and do, but field work means it's off the drawing board. It's not just a theory. It's not just on a board. You actually are doing it. When do you think actually, if all goes well, that we're storing CO2 in North Dakota?
Boy, that's a tough question to give a direct answer to. As you say, there's a lot of different steps in the process. I mean, what we're doing with this stratigraphic test well is we're generating a lot of data that's going to go into a permit for what's called a storage facility or a CO2 storage complex. Those are the wells into which you'll inject the CO2. That process in itself is anywhere from a year or so to step through that process, and then of course. Minnesota has got the capture side of things. They're right now going through some testing on the capture side of things. Scott, I hate to speak for Minnesota on what kind of timeline they've got, but it's certainly not. We're not talking decades. I mean, we're talking a few years is what the timeline is.
By the way, I love Minnesota Power's attitude towards this. They've not been one to. Yeah, I mean, it's just fantastic. It's like, let's solve the problem. Let's not bemoan, how many people are against us. Let's solve the dang problem. and they've really been great about it. Can you give us folks that are not doing subsurface research and development as a geologist day in and day out a sense of what, if this goes as planned, if you're able to have this all work out as planned, what will change? What will be the thing that will shock the energy world?
Well, I think what'll shock the energy world in the current climate is, no pun intended there, is continued ability to use our coal resources. And there are, as you're probably aware, there's like 800 years worth of coal resources in North Dakota alone. And to be able to generate that electricity in a way that takes environmental stewardship seriously, we're able to, not release that CO2 as a greenhouse gas, help mitigate climate change, and to be able to continue to operate those coal-fired power plants in a way that allows it to be environmentally sustainable. I think that right there is a game changer, even though we're kind of changing back to something that has been in our portfolio for a long time. But I just think that reliability and sustainability of coal-fired electricity is really essential, not only to North Dakota, North Dakota's power grid, but really to the world and the future developing world. And to be able to do that in a way that reduces the amount of CO2 that goes in the atmosphere, I think is huge. And as you mentioned, to be able to capture that CO2, and some of it maybe goes into these deep geologic formations for storage, but as you mentioned, there's huge opportunities for using that CO2 for enhanced oil recovery, especially in the Bakken. I think, you may have followed that. So we've been looking at that for a long time. And I think we're getting closer and closer to cracking the EOR nut in the Bakken. And to have that CO2 from a place like the Dakota Power Plant or other power plants in North Dakota is going to be a really essential part of sustaining the development of the Bakken and really sustaining the North Dakota economy for decades to come.
Well, we appreciate it. We're rooting for you. So let everybody know that this is an exciting project. We're all watching very closely and wish you the best of luck on it. Jim is the Director of Subsurface Research and Development at the Energy and Environmental Research Center. Thanks for the time, Jim. We appreciate it.